Okay, so today we're going to do 2.9 calculus of the hyperbolic function. I believe we don't learn, right? Hyperbolic function. So this is the combination of a function, which is natural log function, exponential function, basically exponential function, not the ln, right? So exponential function, e to the x power and e to the negative x. And this is for engineering and physics major people. So they study of water waves and vibrations of elastic membrane, okay? So now then, like this, linear function, we know there is a straight line, linear. Quadratic function, we have ax squared plus bx plus c form, right? Cubic function, we have x cubed. Then polynomial, we had the definition of a polynomial, right? And absolute value, then we have absolute value function, right? Then hyperbolic function looks like this. Let me write down. So we read hyperbolic sine function. So basically hyperbolic trig function, but sometimes we omit trig function, so just a hyperbolic function. So hyperbolic of sine of x, okay? So this one, definition of the function, right? So this is e to the x power minus e to the negative x over 2, okay? Now, always similar with, there is also this hyperbolic of cosine function. Then this will be e to the x plus e to the negative x over 2. Okay, let me give you a little bit sense of this function. So we know that the trig function from unit circle, right? So so if we have the point here, too big, then the x represent cosine, let's say t, okay? Y represent sine t, right? Okay. Also, we called this is circular function, right? So this is from unit circle. Yeah, so circular function. All right, so this one, we have a Pythagorean identity, which is x squared plus y squared equal to 1, right? That's why we said that x represent cosine t squared plus y represent sine t, so we have a sine squared t equal to 1, right? Now, we have hyperbolic function come from hyperbola. Hyperbola. So this graph looks like this. Looks like that. Looks like a parabola upside down, right? Upside down or side down, whatever you call it. Okay, so these represent like hyperbolic cosine of x, okay? Let me see t, since we are using t. And the second coordinate, which is hyperbolic sine t, all right? Okay, this one, this graph represent, which is x squared minus y squared equal to 1, okay? So we called hyperbola function. Okay, now look, since we said that this is a represent like x, this is a represent like y, like a unit circle there, right? Then look, x represent here hyperbolic function of cosine t square minus hyperbolic cosine sine square t equal to 1, right? All right. Let me show you this identity. Okay, so we have this. Now, hyperbolic cosine t, which is, look, this one, right? Oh, okay. E to the x plus e to the negative x over 2. Okay, minus, and don't forget we have to square. Let me using t, since they're using t, it doesn't matter. Let me see just the x. How about that? Okay, just a variable, right? Okay, now hyperbolic sine, which is here. All right, now square them. Okay. Oh, thank you. Thank you so much. So sine, normally the square is next to the h, all right? Okay, now I want to factor out 1 over 2 and then square, which is 1/4, right? Then we are using this a plus b square, which is a square plus 2ab plus b square. Okay, now we have e to the 2x minus 2 times the first term, second term, and second term squared. Okay, now same for the second term, which is negative 1/4. Now we are using negative for the first term, right? So e to the 2x minus 2 times e to the x, e to the negative x, plus e to the negative 2x, right? Okay, now let us simplify that, right? We can simplify. Now, we can simplify that with 1/4 and with this, right? Because addition, subtraction, right? Now, we have only middle term left. So middle term has, we do distribute, which is 1/2. And then e to the x plus negative x. And minus plus again, 1/2 to the x plus negative x. Yeah. So that is, oh, wait. Something wrong, huh? Negative is positive. Oh, I copy wrong. This is a positive, right? There is a positive. So we will have a positive. Okay, then we have 2, and then the e to the 0 power, right? So 2 over e to the 0 power. E to the 0 power, what do you get?
1.
1. So 2 over 2, and we have 1, right? Which is 1. All right? Is it clear? This is how we get the identity here. So let me just summarize. So we have hyperbolic of cosine x minus hyperbolic of sine x, x equal to 1. Okay, very similar with the trig identity, which is the Pythagorean identity. Cosine squared t plus sine squared t equal to 1, right? In this case, it's subtraction. All right. So you guys have a little sense about the hyperbola function, and then we have a hyperbolic function in this case. So basically hyperbolic trig function, right? Okay, now let me write down all the definition, all the functions of the rest of hyperbolic functions. Oops. So we have hyperbolic of tangent x, okay? Then we know that this is hyperbolic of sine over cosine, right? Now, so numerator we have this, and denominator we have that. Okay, now hyperbolic of cotangent x, then reverse, right? So which is hyperbolic of cosine, hyperbolic of sine, then we do reverse. Now we have cotangent, so hyperbolic of secant x, which is, they have, let me see, 1 over hyperbolic of sine x, which is sine, which is positive. Is it positive or negative? Let me see.
It's negative.
It's negative. Sine is negative. Okay, good. So 1 over e to the x minus e to the negative x. That's correct. Sorry. 1 over or 1 over, right? Is it correct? Okay, hold on a second. They give us different function for the hyperbolic of cosecant and hyperbolic of, aha, I got wrong. The definition is over 2, right? That's why. Can you see that? 1 over 2. So over 2. So this will be 2 over e to the x, negative e to the negative x. Okay? Now, hyperbolic of cosecant x, which is 1 over, I screwed up. Sorry, I screwed up, right? So this one should be here, right? Yes. And this one will be 1 over hyperbolic of cosine x. So 1 over, and then that is positive. So this will be 2 over e to the x plus e to the negative x, right? Okay, let's check that. Okay. All right, that's okay, right? Now, let's talk about the graph, because since this is a function, there's graph, right? Okay, let me draw.
You still have to change the negative in front of the negative x of the cosine.
Cosine.
1 over e to the x plus e to the minus x will it should be positive, right? Not negative x. Over 2.
Over 2?
It has to be positive, right? The negative x, that the exponent is
Okay.
negative. It has to be
Exponent?
positive.
Hold on a second. Exponent.
No,
Exponent. We have this.
No.
We have this. We have that.
Okay, both are negative.
This is a negative. This is a negative.
Oh, the only one it changes the one in the middle, right?
Yeah, on the change in the middle. Yes.
Only. Okay.
Thank you. So everything is correct. I did not make a mistake. Is it correct?
We trust you.
Ah, thank you so much. So nice. All right. Don't trust me. I make a lot of mistakes. Especially my 8 o'clock a.m. algebra course. I make a lots mistake. I cannot wake up at a.m. My brain does not work. Okay, so
you have a classes at 8 a.m. every day?
yes. Okay, let us do this. Oops. Okay, so we know, let me draw. This is a y equal to 1 over 2 e to the x, right? Because we know the exponential like that, right? 1/2 means that we stretch vertically, right? Stretched vertically. The factor of 1/2, right? All right. Then I want to write down, I want to graph y equal to -1/2 e to the negative x. What is it telling us? We did that before, reflect about x-axis, right? So we're gonna draw like this. That is a reflect about the x-axis, right? Now, what is this? Reflect about y-axis, right? So, okay. How do we reflect? Let me think. That. Oh. So I got like this. Yes. It's okay. Yeah. Better? Okay. All right, then let me erase. I want to draw hyperbolic of sine x. So this will be like that. Hold on 1 second. Okay. This is y equal to hyperbolic of sine x. Okay, now so we go to the we have, once again, this is y equal to 1 over 2 e to the x power. Then this will be, oops. This will be y equal to negative 1/2 e to the x power. No way. Negative x, right? This reflect about the x-axis. Yeah. So that, right? Okay. Now then, hyperbolic of cosine, we draw this way. Sorry, it's a little bit ugly. Okay. So this is y equal to hyperbolic of cosine x. Okay. Now, tangent, we get so we have, I forgot to show you. So maybe I can show you one Desmos because Desmos is hiding there. So let me show you Desmos. So Desmos, we have, look, function here. Now there is more scroll up. Then we have, can you see that hyperbolic trig function there? So I want to draw hyperbolic of tangent, right? X. Okay, so they're not nice here. They must be like smooth like that. Oh, I should have. Okay. Let me draw, okay? Because I showed you how to draw by Desmos, right? This one looks like this. Let me go back. So this is the positive one. Here is negative one. So we do it like this. Like arctangent, right? Yeah. So we call this is hyperbolic tangent. Okay, now rest. Let me just bring the screenshot here. Where is it? This one? Right here, okay? So the picture, the graph is like that. Okay, now. Ready for the derivative? Okay, let me.
Can you scroll up just for
Sure.
1 second?
Sure. Yes, sure.
Yeah, okay, see you.
Okay. Let me bring one more identity here. After him. Okay. All right, so I want to bring one more identity. So screenshot. Where's identity? Okay, there we go. Cut. Okay, so identities involving hyperbolic functions. So it looks like that. Very similar with the trig function identity, right? Okay, so I showed you number 5, right? And then I'm gonna show you number 6. And then this one like a even function, that's where we get that. Other function, that's why we get that. Same as the trig function, right? So let me see. We have hyperbolic cosine square x. And some people just read because too busy to read, right? Hyperbolic cosine x, hyperbolic sine x, hyperbolic tangent, too busy. So some people just read cosh, shinch, right? Okay. Equal to 1. Now we multiply by the hyperbolic of cosine x every term. Square, basically. Oh, position is not right. Okay, now we know this is 1. What do you get? Second term?
Tangent?
Tangent, hyperbolic tangent. Good. Squared. Then we get, what do you get? The last term, right side.
Secant
Yeah, secant square.
hyperbolic secant.
Good. Hyperbolic secant square. Good. Okay. So that is that. All right. Now we do derivative. That's why we need to do this one, right? So derivative. We want the derivative hyperbolic sine. And I'm going to show you only this. Then look, we have exponential involved with in the middle in the negative, right? So e to the x minus e to the negative x, so over 2. All right. So we derivative, then we do term by term, and then there is a constant, the coefficient, so we take out, right? So this will be 1/2. We do derivative e to the x, which is e to the x, right? We do derivative e to the negative x, then e to the positive e to the negative x, and then chain rule, right? So we get positive e to the x. Make sense? Okay. This is how we get the positive there. All right. Then, oh, sorry. Can you recognize this one? What is this?
It will be cosinus.
Good, hyperbolic cosine x, very good. So this is a hyperbolic cosine x, very good, okay. So we do derivative of hyperbolic sine x, then we get the hyperbolic of cosine x.
You forgot to put 1/2.
And the 1/2.
1 divided by 2.
Oh,
What happened with the 1/2?
Yeah, you forgot to put 1 divided by 2 in the beginning of cosinus hyperbolic x.
So this is the same as, hello, this is the same as, this is the same as e to the x plus e to the negative x over 2. Same thing.
Oh, yeah. Okay.
Yeah. All right, now you can recognize. Okay. Oh my goodness. What's wrong? Oh, I cannot make straight line there. All right, so then what's the derivative? Oh my goodness, what's, oh, I see. D over dx. If we do derivative of a hyperbolic of a cosine x, then we get hyperbolic of sine x. This is different with the trig function, right? No negative sign, right? And if we do derivative,
A question, Miss Lee, is this one that is cosine x is the last, is the final answer, and this is another one, or is?
yeah,
Would you
this is the
continue?
final answer.
Okay, and so
So
this
we-
is
we
a
do
second one,
derivative.
another one, right?
Yeah, we do derivative of a sine, hyperbolic of a sine, then we get the cosine.
Okay,
Hyperbolic of a
okay,
cosine.
okay, so that's a different, okay, got it.
All right, so we have, it's hard to say, huh? Hyperbolic, secant x. Hyperbolic cotangent x, which is negative hyperbolic cosecant square x. And we have hyperbolic secant x, which is give us a negative secant hyperbolic x and hyperbolic of a tangent x. Ooh, we have one more. We have hyperbolic of a cosecant x give us the negative cosecant hyperbolic. Said late. Hyperbolic, say late. Okay, so what's the difference in the trig function? This is the difference, right? We have no negative, we have negative there. Yeah, but then everything is the same, right? Only difference there.
So they're basically all the same of the trig function
Yeah.
derivatives, except for just that one negative
Yeah,
on the secant.
highlighted with the yellow.
Okay,
Yeah.
thank you.
Good. All right. Okay. Then integration is the same thing, right? So integration with the same thing. So we do integrate whatever we get, hyperbolic. They just give it to you, then du, which is hyperbolic of cosine u plus c. Now we have hyperbolic of cosine u du, which is hyperbolic of sine u plus c. Now we have hyperbolic of cosecant square, not square there. U du, then we get the hyperbolic of tangent u plus c. Now we have hyperbolic cosecant u cotangent hyperbolic, I said that right, u du, negative cosecant hyperbolic of negative cosecant u plus c. Now a hyperbolic of a cosecant square u du will be negative cotangent with a hyperbolic u plus c. That's it, right? 6. Oh, we're missing one.
I'm missing cotangent. No.
1, 2, 1, 1, 1, 2, 3, 4, 5. What's missing?
Tangent?
Tangent. So we have a tangent, secant and tangent, right? Good. We're missing secant and tangent. Then we get negative. So we're gonna get the negative, right? Because they don't have a negative sign there. Okay. Here, this one. I'm talking about this one. All right. Okay. All right, then we're gonna do find the derivative. The first one, hyperbolic sine x squared. How do you do?
I guess you'd make x squared like u, and then derivative of u would be 2x. So and then so then you'd put that in the front, and then it'd be so like 2x cosine.
Excellent. So yeah, so we have a hyperbolic.
Cosine.
And then chain rule, right?
Exactly.
So we get two x hyperbolic x squared, right? Very good. Now we have this. So this problem, compare with the x squared with the in the function squared. How do we do? So basically this is the same as that, right? Cosine hyperbolic square, right? Same as. Okay. How do we do?
It will be sinus 2x sinus.
Good. Then we do derivative. Oh, no, hold on. We are using power rule first, right? So we're using power rule. Then we do derivative, chain rule, right? Correct? You guys confused because we just did the integration yesterday, maybe that's why. So we have 2 hyperbolic cosine. Then what's the derivative of hyperbolic cosine?
Hyperbolic sine, right?
Sine, so hyperbolic sine.
Sine. Yeah.
Very good. Okay. All right. Number 3, we have derivative of hyperbolic tangent x squared plus 3x. So how do we derivative?
Do we make u substitution?
Oh, you guys get confused with the integration. Derivative of hyperbolic of tangent, what do you get?
Oh, is it more like a chain?
Secant
like a chain
hyperbolic
Squared, secant squared. Then we have that. Then we're gonna make a chain rule.
Yeah, chain rule.
Then what do you get?
2x plus 3.
2x plus 3. I'm writing in front so that you cannot, you don't multiply with x squared plus 3x, right? So we have a hyperbolic secant square x squared plus 3x. Okay, good. Last one. So we have a hyperbolic secant.
Oh, yeah.
Minus secant.
Oh, yeah. So we got to do the chain rule again. And
So this means that, oops. Right? So we are using power rule first.
yeah,
Then we are using chain rule.
and we got to find the derivative of square root of x.
Okay. What's the derivative of hyperbolic secant?
Oh, yeah.
Minus
What do you mean? Oh yeah, I'm asking you.
Oh,
No,
no.
oh yeah.
minus
Minus secant and 10, right? So
secant.
not oh yeah. And negative secant and 10. Okay, hyperbolic. All right, now chain rule again. Okay, what do you get? So square root of x with the derivative. That'll work. Derivative
2/3.
2 over square root of x, right?
Oh yeah, correct.
And rewriting everything. Okay. So you guys okay with this, right? So derivative rule is easy. Just follow the instruction. I mean the formula and then chain rule, right? Integration is a little bit hard, right? Okay, let us do integration. Oh. Let us just do 2 problems. Can you please hold? I will answer that in the chat later. Is okay? Okay, so we do integrate. Now, we're gonna use your sub, right? Which one is you? You.
ux. X squared.
X squared good, du, which is?
Uh, 2x.
2x, good, dx. And then we're gonna divide by 2 both sides because we don't see the 2 there. So we have 1 over 2 du, which is x dx, okay? All right. In this case, please don't use a u sub, just to realize that we need making this one channel, so there's a 2, 1/2. Okay, and you can just think about what is the integration of hyperbolic of cosine. Okay, so in the YouTube, there's a list method how to integrate easily without using new substitution. Okay, maybe I can post in the link in the announcement. All right, so this is easily to, what was it? X. So, okay, so we have u 1/2 cosine, not cosine, hyperbolic cosine, which is that's u. Dx will be du, right? Now, 1/2. What's the integrate antiderivative of hyperbolic of cosine? This is a really good one, right? We don't have to think about the side, the negative, positive like that,
Sine,
right?
sine, yeah.
Fine, very good. Always confusing. Is it negative? Is it positive, right? This is really good. Okay, second one, we have the hyperbolic tangent. This is not easily to think, right? Okay, so this will be sine, hyperbolic sine over hyperbolic cosine, right? Now, then, can you see that, this one? Can you recognize this one?
Yes, we can. It will be tangent.
Okay, let u equal to, what do you want to set up?
X.
Hyperbolic cosine.
Oh, okay.
All right. Then, what's the derivative?
Sine hyperbolic.
Hyperbolic sine, good. Dx. So we have that one, right? So this will be du over u. And there is an expert about this one. You're very good, this one.
Ellen.
Ellen, good. Yeah, I told you. You're expert about this. All right, then, Ellen, u was hyperbolic of cosine plus c. Okay, good. All right, so we do derivative integration of a hyperbolic trig function like this. It's no problem, right? Okay, now we're gonna do inverse. So inverse, let me see. We have, you guys write down everything? So we have an inverse of a trig hyperbolic function. Since we don't have time, inverse hyperbolic functions. Okay, we denote like a little -1 on the top. We know that. Let me show you the graph here first. Screen. Oh, not this one. Was it? No, it's not. So sorry, one more time. Cut. I did not cut. Okay. This one delete. So inverse function, it must be one-to-one, right? So the hyperbolic sign was okay. We checked the horizontal line test in order to be inverse one-to-one function, right? Okay. So in order to be inverse, must be one-to-one. Then in order to make a one-to-one function, we have horizontal line test, right? So, but then cosine, the hyperbolic cosine looks like a hyperbola, looks like a parabola, right? Then they violated about the one-to-one function. So they cut only that part, like that. Then the inverse function, we have y equal to x reflect. That's why they got like that, okay? And the hyperbolic, the tangent was, we had, I cannot, all right, never mind. Let me draw here. So we had like this, right? And then we draw like that, right? And then this is the inverse. So they're drawing this way, right? Reflect about the y equal to x. Yeah, that's the inverse function. So this is inverse of hyperbolics. Can I use this one? Okay. So A inverse of hyperbolic of sine, and B is inverse of hyperbolic of cosine, then inverse of hyperbolic of tangent, and so on, right? Okay, so looking at that, so also we can think about the domain and range there too, right? Okay, now I want to show this. Let's say that y equal to hyperbolic of inverse function. Okay, inverse function, we can swap x and y, so we do that. So we're gonna have they change y, these two. We say that we get hyperbolic y equal to x. Okay, now with the derivative, so we have hyperbolic of sine y equal to x. All right, so we do derivative of, I have to give it to you a hint, use implicit differentiation. Okay, so this will be, what's the derivative of a hyperbolic sine?
Cosine?
Yeah, hyperbolic cosine x, and then, I'm sorry, y, then we see the y, so we're gonna say that dy over dx, yeah. What about the right side? We do derivative of x, what do you get?
Just one.
Yes, now we solve for dy over dx, then we divide by hyperbolic cosine y, both sides. Then we get dy over dx, which is 1 over hyperbolic of cosine y. Okay, then look. I showed you identity earlier, so hyperbolic of cosine square minus this one, right? And hyperbolic of sine square y equal to 1, right? Then if we solve the hyperbolic of cosine y, then square root of 1 minus sine square, no, not square, hyperbolic, right? Make sense? 1 minus hyperbolic sine square y, right? Okay, so we're gonna use that. So it's 1 over square root 1 minus hyperbolic sine square x. Okay.
Makes sense.
Makes sense. Very good. I said y, right? Okay, then look. Can you see that we say that hyperbolic of a sine of y equal to x? We're gonna set it up. We had, then we can say the square, and we can say the x squared, right? So we can replace 1 over square root of 1 minus, we can say that x squared there, okay? So we derive the formula, yeah. Okay, now, so let me write down everything. We have derivative of inverse of hyperbolic of sine. Then we get 1 over, wait a minute. Sorry about that. This should be plus, huh? Can you see that? Because 1, we move to the right side here, so it should be positive, isn't it? We move to the other side, so it should be positive. Okay, so we will get, good thing I wanted to write down one more time, otherwise I did not catch that. All right, and we have inverse of hyperbolic of cosine, then we get 1 over square root of x squared minus 1. Now we have inverse of hyperbolic tangent, then we get 1 over 1 minus x squared, okay? We have a derivative of inverse of cotangent, then we get 1 over 1 minus x squared. Now we have a derivative of inverse of hyperbolic secant x, then we get negative 1 over x to the 1 minus x squared, okay? Now, One more with the derivative. Whew. Inverse of a cosecant hyperbolic. Then we get -1 over x and square root of 1 plus x squared. Okay. All right. That is a derivative. Okay. Since we said a derivative, let us talk about the integration too.
The tangent and cotangent is the same answer. 1 over 1 minus x squared.
Let me see.
Tangent and cotangent inverse is the same.
Oh, hold on 1 second. Thank you. Yeah, book said the same thing. Here you go. Let me do integration, then we find out which one is which one, right? Okay, that's good to know, right? We have same, right? We do derivative, we get the same answer. Then what if we do integrate, right? Antiderivative, let's do it. So we have 1 over square root of 1 plus x squared. They do the x squared or u? They do the u. Okay, let me just using book. So they have a u squared du. Then there will be inverse of hyperbolic sine. Okay, and they have 1 over square root of u squared minus 1. Then we have inverse of a hyperbolic of cosine. Now, there we go. 1 over 1 minus u squared. Look, they have two different answers. Look, one is inverse of hyperbolic if the absolute value of u is less than 1, and this one is greater than 1. 1 over u square root 1 minus u squared du, which is negative hyperbolic of inverse u plus c. And then one more, so sorry, lot of information. U squared du, negative cosecant inverse hyperbolic u. So you must know the previous order formula so that you don't confuse with this one, right? You don't have to memorize this one. Okay. Now let us do problem. So we do hyperbolic inverse x to the 3rd power. Okay. So this will be the form, right? We have a square root 1 plus, we have whatever inside the function squared. Now we do chain rule, right? So what do you get? Derivative of x over 3.
Minus 3 over
1/3? Yeah,
1/3,
1/3,
yeah.
thank you. Yes, 1/3, right? Okay. So that is, let's just write down this way, okay? I don't want to make a common denominator, simplify inside. Okay. All right. So how about this? So we do derivative inverse of hyperbolic. Make a channel, so 2 of tan inverse of hyperbolic function tangent, right? Then we do derivative of what is the inverse of hyperbolic tangent. Can you please take a look at your lecture note? What is that? 1 over 1 minus x squared, right? So 2 over 1 minus x squared. Okay? Okay. Number 3, we have derivative of inverse of hyperbolic cosine. Okay, we're looking at the formula. There is 1 over square root of x squared minus 1. So this will be 1 over square root x squared. So in this case, 3x squared minus 1. And then we do derivative. 3x. So we do derivative of 3x. What do you get?
3.
3. Thank you. Okay. The last one, we have a derivative cotangent inverse of hyperbolic cotangent cube. So channel, I'm sorry, power, so 3 cotangent inverse hyperbolic square channel cotangent, right? Then inverse of hyperbolic cotangent, what do you get? We're looking at the formula, so there is same as tangent 1 over what is called
1 minus x squared.
oh cotangent, let's see, 1 minus x squared, correct, right? Yes. Okay, then there is same as one minus x squared, right? Is it clear?
Yeah.
Okay. All right. So just one integration. How about that? Since we talked, then we are done. All right. So this one we can say that this is 2x squared minus 1. What can you see? Antiderivative of this one. So this is the same
Secant
as,
squared?
oh,
Oh, maybe
yeah,
cosine?
so inverse of a hyperbolic of cosine, right? So we have to have a u sub there, 2x. So let u equal to 2x, du equal to 2 dx. So we don't have a 2, so we have to make a 2, right? So 1 over 2 du, which is dx. So we have 1/2 du over, that is the u squared minus 1. Now then we can realize that that is the inverse of cosine u. Yeah. And there is 1/2. Inverse of hyperbolic u was 2x, right? Okay, if you are using my method, this method, right? Then we are doing this one. You can just realize, oh, I need 1/2 there, and then just directly like this, okay? All right. Thank you for coming.